then we'll do vocabulary, and then we'll do a little bit of some central practice too. So again, you have your box of words near the bottom of this page, and then we have the definitions here that we're going to fill out. So what do you guys think would be the correct word for the definition coplanar lines or planes that never intersect? Parallel or parallel. So we're going to have parallel lines / planes. All right, they can be lines or planes. Two important aspects of this definition. Coplanar is specific for the lines, because you can't have coplanar planes, that doesn't make sense. But when you're talking about lines that are parallel, they have to be in the same plane, right? Two lines are always in the same plane if they're not touching. Right, so if you think of two parallel lines, you can always have a plane that goes through them. So that is why that is involved in the wording of the definition. They have to be coplanar. And again, they're never going to intersect. So if you guys want to draw a little diagram, now draw two lines here as best as you can, illustrating parallel. In order to know that lines are parallel in a diagram, they must have this symbol on it. If they do not have that symbol, then you do not know that they are parallel. So they look like little arrows. Sometimes they make them a filled-in kind of triangle arrowhead type thing. It really just depends on the font or whatever they use for the diagram. So if it looks like an arrow, that proves that the lines are going to be parallel. Now here's a confusion that I've seen kind of come up in the past. Do you think parallel means the same thing as congruent? Do parallel lines have to also be congruent? No. Because remember, you can have like a really short segment here and a longer segment. As long as they're not touching and they're in the same plane, that's parallel. So don't be confused that parallel and congruent mean the same thing. Now, if you guys are seeing in writing, if I wanted to say that two lines are parallel without the physical word parallel, because mathematicians are lazy, we use this symbol right here to stand for parallel. So it looks like a really long, skinny 11. So if you were going to say that out loud, you'd say A is parallel to B. That's your symbol. All right, next up, non-coplanar lines that never intersect, but they're not parallel. They have a different name. What are non-parallel lines that still don't intersect? Yes?
Oh, perpendicular?
Nope.
Oh.
Skew. Skew lines. Skew. Not skewed. It's just skew lines. Look at the two words. Look at the two sections of each definition that I underlined. What's the difference? These are non-coplanar. Right? So parallel lines have to be in the same plane, but skew lines are in totally different planes. The best way that I illustrate this is if you think about parallel lines, they would look like this, right? Skew lines look like this. Parallel, they're going in the same direction, the same plane. Skew lines are like this. They're going in different directions, but in different planes. This one's going to go up and down forever, this one's going to go horizontal forever, and they're never going to touch. So you can have lines that don't touch, but they don't have to be parallel. They're called skew, right? And so the reason why they're not parallel is because they're in different planes, and that's what makes them go in different directions. Okay? All right, we don't have any skew planes, because if you think of a plane going on forever, if I had a plane like this going on forever, and a plane like this going on forever, it would eventually come and hit this plane. So there's no such thing as a skew plane, because of how infinite they are in covering space. So it's only skew lines. All right, what are lines or planes that intersect to form right angles? There's your perpendicular. And then 38 perpendicular lines. Alright, so just like for parallel, perpendicular applies to planes as well. So if you think about like two pieces of paper, right? When they're like, well, can't hold them perfectly, but when they're like this, straight upright, and they don't cross each other, those are parallel planes, right? If they were to cross like this at a 90-degree angle, right, those would be perpendicular planes. So it works the same for planes as it does for lines. If you guys want to draw an illustration, there's an illustration of perpendicular lines. They're only going to draw one of those boxes. There are 4, but they're only going to draw one. With the understanding you can extrapolate that there are 3 others. The notation for perpendicular is an upside down T. So if you wanted to say A is perpendicular to B, you would use that symbol right there. I think we've mentioned that before in proofs. All right, what do you call a line that intersects 2 or more others? A transversal. So what I just drew, the dotted line, the dashed line is a transversal. The 3 that I drew originally, if you can draw another line that slashes through them, it could be 2 or 3 or 4 or more. If you can draw one line that crosses all of them, that line is called a transversal. Okay? So we're going to be working with diagrams that have transversals for basically this entire unit. So that's why I introduced that word here. Now I know none of these are drawn into your guys' notes printed, but you're going to draw them in a second. Those are all of our lines. Our parallel, perpendicular, skew, and transversal. That's all we need to know about lines. The rest of this is all about angles, and we do focus primarily on angles in this unit. So the angles are super important. So before we get to this definition, go ahead and draw that little diagram. It looks like a slanty H kind of thing. We have 2 lines and a transversal. So if you could draw that little diagram right there. Yeah, but we're going to do them one at a time. Because what we're going to do, this is why I need you guys to have your colors. Because we're going to be identifying angles in these diagrams, and you're going to draw little dots with your colors to show them. That's why I needed you to have colors. All right, so our first type of angles that we're going to talk about are angles that are inside or between the 2 lines that are being crossed by the transversal. What do you think you would call those angles as a whole when they're inside or between? Interior. Interior. So these are interior angles. You're right, please. Interior angles. So everybody pick your favorite color that you have. Once you have this diagram marked, we're going to mark all of the interior angles with a dot. Right? So this one, this one, this one, and this one. Those are all the angles that are inside or in between. All you should be highlighting are the interior angles, which are just these 4. Alright. Do you guys understand what I mean by inside or between? Listen. Oh my gosh. Guys, look up. Do you understand what I mean by inside or between the 2 lines? Yes. So that's going to be important. Yes? Okay. Now, when we have interior angles, you guys know there are 4 of them? We're going to pair them up. Okay? In 2 different types of relationships. This one and this one. We have 2 different types of ways to pair them up. So the first one, we're going to have 2 interior angles that are diagonal from each other and lie on opposite sides of the transversal. What do you think these are called? They're a type of interior. Alternate. So these are alternate interior angles. So you guys will need 2 different colors now. We're going to mark 1 pair of alternate. Go ahead and draw this diagram, this H shape again. We're going to draw or mark 1 pair with 1 color and the other pair with another. So once you have this diagram drawn, what I've drawn in blue, that is 1 pair of alternate interior. Does everybody understand why they're alternate? Do you guys see how they're on different sides of the transversal? Yeah. One's above and one's below. That's the alternating part. The fact that they're inside of the 2 lines is the interior part. So the 2 pieces of the name tell you where their position should be. Okay? There's another pair. Change colors. There's also one right here and one here. There's always 2 pairs of each of these. Okay? Does everybody understand the alternate interior? So They're interior angles that are on different sides of the transversal, diagonal from each other. Is everybody with me so far? Yes. Okay. Now we're going to talk about the definition underneath that. Oops, I don't want that one. Oops, I don't want that one either. Two interior angles that lie on the same side. Consecutive. Consecutive interior. Consecutive interior. You do need both of those parts of the name, telling you whether they're inside or not, and then whether they're on the same side of the transversal or not. So consecutive interior means that they're both inside of the two lines, but now they're on the same side of the transversal. So instead of being diagonal, alternating, they're on the same side. They're following each other. So you have one pair right there, then you're going to pick a different color. We have another pair right there. You guys see that? Yes. So you have your alternate ones, which are one above, one below, and you have your consecutive, which are on the same side.
Oh, hey.
All right, is everybody okay with interior and the two types? Yeah? What do you call angles that are outside? Exterior. Exterior angles. You're going to pick a color and go ahead and highlight those as well. So the exterior angles are not going to be in those four positions. They're not outside of the two lines. Instead of being inside, they're outside. Yes.
If you have one's on the left, one's on the right, the same color.
Yes. We're just identifying. Listen, guys. If you're working ahead or remembering while I'm trying to show the diagram, it's confusing for the people around you. So these should all be the same color because I'm just identifying exterior in general. We're about to divide them up into pairs in a second. So right now we just have in general 4 exterior angles. All right, we're going to repeat exactly what we did for the alternate and consecutive, but now we're going to do it in the context of exterior. So this next set, 2 exterior angles that are diagonal from each other. Alternate exterior. Alternate. Oops. Okay. These are your alternate exterior. Draw your diagram if you haven't yet. We're going to do the same pattern as we did before. So if I have a blue angle here, that's outside. Should I draw the next one here in the upper corner? No.
Down. There.
Remember, alternate, one's going to be on top, one's going to be on bottom. And then you have the other set right there. They should make a diagonal kind of relationship from each other. All right, 2 exterior angles that lie on the same side. Good. Consecutive exterior. Right? So those are still going to be outside because they're exterior. They're still going to be outside the 2 lines, but they're on the same side of the transversal. So it should look like that. Remember, the exterior versus interior tells you where their position is. Consecutive versus alternate tells you whether they should both be on the same side of the transversal or be diagonal from each other. All right, is everybody good up until this spot? Yes, there's only one word left. The last one is corresponding. Oops, that's a D. Well, I got messed up. All right, corresponding. Corresponding is very different. There's no interior versus exterior. There's no consecutive versus alternate. It's just a totally different thing called corresponding. Corresponding is another word for matching. So essentially the definition of corresponding angles are two angles that are in matching positions at both of the intersections in your shape. So see how you have two different intersections here and here, two little crosshairs? So your corresponding angles are in the same position at each intersection. So if I choose one color, if I choose one angle to be the upper left of this intersection, the corresponding angle would be in the upper left of the other intersection. They're both in the upper left corner of your crossing.
I remember these.
So this is where you guys are going to need to use 4 colors total. So there are 4 different pairs. There are 4 different sets of corresponding angles. The blue ones that I've just drawn. So the blue are in the upper left corners, the red are in the upper right corners. I don't even know if I have 4. A lot of black. And then you have the lower left corners, which are matching. And the lower right. So you need 4 different colors. Or your pencil could be one of them. That's why I said to get 3, but your pencil can be one. All right. Go ahead and finish with that diagram, please. All right, so everybody listen up. Stop chit-chatting, please. It is crucial that you guys are able to identify these types of angles, and we're going to practice them on the next page. But it's crucial you guys are able to identify these relationships, or you will not be able to do lessons 2 or 3 if you are not able to identify the angles. So we'll leave that alone for a second. Let's take care of our lines first, and then we'll go and spend more time on the angles. So let's just take a look at this picture right here. My first question for you is find all the lines that are parallel to VZ. VZ is right here. So how would I find all the lines that are parallel to that? All the other sides with the double arrow. So that's W, right? Is there more?
Yeah.
What? Say again?
Yeah.
TX and UY. Everybody see that? We know that they're parallel because there's a little symbol there in the picture. What about segments that are perpendicular to UY? Perpendicular means that they come together to make 90 degrees.
ZY
Okay?
and VU.
ZY, VU. There's actually more. XY and TU. Does anybody have?
Oh,
So when you guys are looking at the picture, you guys see the 90-degree angle, right? One here and one here. So the ZY and the VU are really easy to see automatically because you have a 90-degree angle there. But if you think about a physical box, right? When you're looking at this one, you guys already told me that these 2 lines should be 90, right? What about the one on the top? Comes out, right? All 3 of these work together to create that corner. So that's why you also have to include TU and XY. Right? So you can use a visual aid, or just remember what you know about a cube. You should have 90-degree angles everywhere. If you have one. If you see one, you know that all the other angles surrounding that are going to be 90 as well. Okay? So it should be those four.
Oh, because they're kind of touching on it?
Correct. They all work together to create that corner.
But not the, okay, not the sides, like SW, right?
Yeah, no, that's not over.
Yeah, okay, I heard, yeah.
All right. Name a plane that's parallel to STU. Yep.
WX1.
Okay. STU, if I'm using the same representation, STU is the plane at the very top. So obviously parallel to that is the bottom. So you could name that. You could use 3 letters, you could use 4, you just can't use 2. You have to use 3 or more, and they could be whatever 3 in whatever order you want. Yes?
So it can also be STD.
Yeah, so in naming this plane, they could have also called it STUV, yes. Alright, what is a plane that is perpendicular to WXY, which is the bottom?
TXY.
Yep, TXY.
SWZ.
You could have also done, yep, SWZ. It's actually another one. There's actually 2 more, yeah. Yep, SWX. And then there's one more. BUY. So if you guys think about a tissue box, all 4 sides are perpendicular to the bottom, right? So they have that corner. So you can take any of the 4 vertical sides and they'll be perpendicular to the bottom. Otherwise you'd have a really weird looking box if they weren't perpendicular. Alright, so I know it says A. If you guys were given this on a quiz, you just pick one and just writing all 4 so you guys can see your options. Alright, what's a transversal to segments S, V, and WZ? Remember, the transversal is any line that's going to cross 2 or more others. So what's a transversal to those 2? VZ? That could be one. Is there another option?
SW.
Yeah, SW.
Oh, that means it'll cross.
Yeah. Remember, transversal. A transversal is any line that's going to intersect or cross 2 others. So the 2 lines I'm specifying are SV and WZ. So a line that touches both of them are those 2 sides right here, SW and V. Alright, these next ones are numbers. How many lines through S are perpendicular to XY? 4 of them?
0.
None.
Do you guys understand what I mean by through S?
Yeah.
Like your line has to include S in it.
Yes.
So how many of them are perpendicular to XY?
None.
0.
Yeah.
S is right here. These are the only lines that have S in them. None of them are intersecting XY, so they cannot be perpendicular. They have to be touching XY to be perpendicular. Alright, how many lines through W are parallel to UI?
1.
Just one. And which one is it? WS. Very good. WS or SW doesn't really matter. Alright, so that's just a little bit of practice with your line stuff. Although primarily what you guys need to be worried about are the angles. So if you turn the page.
Oh no.
Oh, look at that.
These look
Oh, I remember those.
No, it's crazy, right?
5. I love colors.
Write down. So at the top of the page, I have some hints. You may not need to use them immediately, but here are some hints. Using colors, particularly highlighters, is really helpful for a lot of students. All right. In the diagrams that we drew on the front, they look like H's, right? You have 2 lines and then kind of one going through the middle. They look like H. You want to be looking for those kinds of H's in the picture. You only need 3 lines total. See, this one has 4. So there's going to be one that you don't need. So when you guys highlight the 2 that are upright and the one that's slicing through, when you just highlight those 3 and get rid of the other line, it makes it easier to work with the picture. Some students don't like to highlight a bunch of times, like over previous highlighting. So they like to redraw instead. Redraw the picture using only the 3 lines that you want. That's also a really good strategy. There's also a cool strategy for finding interior angles. If you guys can draw a Z like this, if you can draw a Z in your diagram, the corners of the Z are always alternate interior. So that's a nifty trick you can use. If you can draw a Z, it doesn't matter if it's upside down, going to the left, to the right. If you can draw a Z shape like this, the inside corners of the Z are going to be alternate interior. So that's a little hint you can use. Now I have to erase that. Okay, so we're going to go through with this picture, and we're going to figure out what the relationship is between the angles given. Quiet, please. All right, I'm looking at angle 1 and angle 5 first. What is their relationship?
Corresponding.
They are corresponding. I'm going to abbreviate. If you were to redraw the picture, it would look like this. You have angle 1 and angle 5 like this. And you draw it like that. Makes it easier to see, right? Corresponding. All right, 9 and 13. Alternate. They're interior. Want me to draw that one? If you're looking at 9 and 13, you have these 2 lines here, and this transversal. You have 9 right here, 13 right there. Alternate interior. Because they're inside of these 2 lines. The 2 lines that you have that create the size of the H, whether it's on its side or upright, those are what you use to determine if they're inside or outside.
Oh, I see. If you just.
Yeah. And that's another strategy you can use, Kaylee, just turning your paper. All right, 6 and 16. How many lines total do you need to create angle 6 and 16 together?
4.
How many lines are you supposed to use? 3. So what do you think? None. The answer is none, and this is significant because sometimes angles don't have a relationship and we have to work with them differently. You guys see how 6 is over here, uses these 2 lines? 16 is over here and uses these 2 lines. They have no relationship to each other. They don't even have a shared transversal. They have 2 separate transversals over these. Guys, it should be 2 lines, 1 transversal. That should be your picture. You don't have 2 different sides of the picture trying to work together. All right, what about 2 and 15? 2 and 15.
None.
It's consecutive interior. Let's redraw the picture. Those of you who need to see the visual. All right, 2 and 15 are right here. You guys see 2 and 15 are right here? So I can redraw the picture like this. Here's 2, here's 15. Now can you see it? Consecutive interior. Draw a little diagram for yourself.
So could you do that the same for if it was you were working with the bottom line?
Yes.
Okay.
So if you're doing like 6 and 9, you could draw it like that too.
Okay, I see.
Yeah. All right, 4 and 14. They are alternate exterior. Good. Brody, are you redrawing the picture? Okay, try doing that, okay? 4 and 14. 14 is right here and 4 is here. You guys see that?
Yes.
So if you have a picture like this, angle, angle, they're outside to their exterior and they're on different sides of the transversal, so they are alternate. All right, what about 12 and 5?
None.
Another none. Catch. Because one of them is exterior, one of them is interior, but they're on different sides of the transversal, so that doesn't work. So 12 and 15 are none. You guys see that? 5's outside, 12's inside. Not going to work for us that way. Corresponding have to be on the same side of the transversal. For corresponding, one's inside, one's outside, but they have to be on the same side.
Wait.
No, because one of them's outside, one of them's inside.
So for corresponding, it has to go on the other side.
No, you're gonna have one outside, one inside. You have to be on the same side of the transversal.
Okay, yeah. So,
Yes. All right. Questions about that first set? All right. We're gonna try this diagram, which is a little bit more tricky. All right. Remember how our diagrams look like this? Typically, look like H's. Now we're gonna start working with A.
oh.
Instead of being an H, they kind of shift the lines a little bit like this. Now it's an A. Watch, everybody. The lines that help you create the angles, instead of being straight like this to create an H, they're gonna move to create an A. So it's still the same, they just slanted more. So you have to be super careful. All right, 1 and 13. 13 is right here. 1 is right there. It actually is none. Can anybody explain why? Colby?
For angle 1, it's using an angle that, it's using lines like this,
Yes.
and then with angle 13, it's using another,
So how many lines total do you need? No, you have
4.
this line,
Four.
this line, this line, and this line to create angle 1. You can't use 4 lines at once, you just need 3. So with this extra line being necessary to create angle 1, it messes up the entire thing. Okay? 4 and 11. Okay, let's draw. Okay, we have these 2 lines right here in this transversal. Wait, what did you guys say it was? Oh, that's my bad. I thought I was looking at 14, sorry.
Is that right?
So yeah, you're right. It's consecutive exterior. I was looking at the wrong angle. 4 and 11 are consecutive exterior, that's correct. All right, 5 and 8. Those are corresponding, good. Does everybody see that? If you try drawing the picture here, you have this one, create 5, and then 8. You have 5 here and 8 here, corresponding. Excuse me. We're not talking about parallels yet. Lines don't have to be parallel yet to create the images. All right, 9 and 14.
No,
What do you guys think?
no.
No, there is one. It's alternate interior.
Oh, okay, yeah.
This is one of the sides of the H have converged for this one. So for this picture, it looks more like an A. So it looks like this, and then like this, and then you have your transversal. 9 and 14, they're inside of the A. You're gonna see how they're inside of the A? You have your A, they're inside, but they're on different sides of transversal. That's the definition of alternate interior. Okay? 6 and 10. Consecutive interior. That's another A shape. You guys see it? You have here, here, and here. Here's 6, here's 10. Are they inside or outside of the A? They're inside of the A, and they're on the same side of the transversal. That's consecutive interior. It might be helpful if you guys draw the 2 sides with one color and the transversal with another. Some of my students like doing that last year, so they could identify which one is the transversal. It makes it a little bit more helpful. What about 2 and 14? Alternate interior. Good. Right, so that was a pretty difficult diagram. I can't say that most of your diagrams will be like that. Some of them maybe, when you're looking at them. More often than not, they're closer to the H rather than the A. But you need to be okay with both. Questions? Again, redrawing or highlighting is a really good strategy if you can't see it in the jumble of all the lines. Okay? Alright, that's just identifying. Now we're going to talk about how do you solve. How do we use these relationships to help us solve? So, like I said in Unit 1, remember when we learned the angle addition postulate and the segment addition postulate, and I said you had to memorize those in case you need them for proofs, and you guys ignored me? I'm going to tell you again, you need to have these memorized for proofs. We will be using those, this unit, as defenses within proofs. You have the corresponding angles postulate. Stop talking. You have the alternate interior or exterior angles theorem and the consecutive interior or exterior angles theorem. This is postulate. You guys remember the difference between a postulate and a theorem? A theorem needs to be proved. A postulate is taken to be true because it's based on definitions that we already know. So the postulate is something that we can take to be true without needing to prove it. These ones we will actually end up proving a little bit later in the unit. Okay? So this postulate states that if parallel lines are cut by transversal, corresponding angles are congruent. So if you guys see that you have corresponding angles, they should be the same in measure. Only if the lines are parallel. So I want you to write nice and big over here. Have to be parallel. For these theorems and postulates to work. In order to solve, the lines have to be parallel. If they're slanty and weird, then you cannot solve. They have to be parallel for you to find numbers. Alright, alternate angles are going to be congruent as well. So if they are corresponding or alternate, they should be same in measure. They can't all three be congruent. So what do you guys think the consecutive ones would be? Supplementary. So if you have corresponding or alternate, they should be the same. And if they are consecutive, they should add 180 because they're something. Okay? A couple of things you guys can use visually to support you. If you're looking at a picture and one of the angles is obtuse and the other one's acute, could they possibly be the same?
No.
No. So to visually guide you, to make a visual correction on what you guys are thinking, if there are different classifications, they should be supplementary and not congruent. So that's another visual check you guys can use. And then this one's super important, the double asterisk. Sometimes the angles don't have a relationship to begin with. So you're going to have to use vertical angles to shift one of the labels that you have to a angle that works better. So sometimes you may need to do that. So keep that in the back of your mind. We're going to start with some easier ones and then work our way to ones that are slightly more complicated. What you guys need to do is just figure out what the relationship is. It's a three-step process. What's the relationship between the angles? Should their angles be congruent or supplementary? Write an equation, solve. Okay? So which variable would you guys like to start with?
X.
Robin. Thanks, my piece of soup. We're going to start with x, right? What's the relationship between x and the 118?
Alternate interior angles.
Good. They're alternate interior. What do you know about alternate interior angles? All right, so what's the measure of x?
180.
Very good. All right. What's the relationship between the y and the 118? What kind of angles? Consecutive interior. And they should be? What's going on with their measures?
Supplementary.
Good. So then, what does y have to be to make that happen? 62. Just like that. What kind of angles are they? What should we know about their measures?
So do we always have to like write out? Or
I would prefer that you guys write it out because we're going to be doing that kind of stuff for proofs. So if you write out what type of angle relationship it is, at least that, maybe not the parentheses part, but at least tell me what the angle relationship is before you solve it.
so like x plus 5.
Well, that's using linear pair if you do that. Which you can do. You can fall back on the unit 1 stuff and do linear pair, but if you're doing one of the parallel line relationships, you have to tell me these two are consecutive interior. Or like. So there actually are two ways to find y. Listen. There are two ways to find y. You could also do linear pair between the x and the y. I typically avoid that though, because what if you got x wrong? Wouldn't that then force you to get y wrong if you tried to use x? So if you double check and you're totally sure that x is right, feel free to do that. But I try to avoid that in case I get one of the variables wrong. Okay? All right. What's the relationship between this angle and that angle? No.
No.
There is no relationship currently. Currently.
Currently?
We're going to be into this trick right here. When they don't have a relationship to begin with, you're going to move one of the angles using vertical angles to where it should be to get a relationship to happen. So could I move the y here?
Yes.
That's valid, right? Because vertical angles are congruent. So forget that. You could also move the 67 if you wanted to, either or, you pick. But if I choose to move the y here, now what kind of angles are they?
Consecutive interior angles.
They're consecutive interior angles. What do I know about their measures?
Supplementary.
Okay, so then what does that mean y has to be?
113.
113. So be on the lookout for those. If the angles don't automatically have a relationship, you can shift blend, one or the other, doesn't matter which, using vertical angles, and then you're good to go. Huh? I know, some of the pictures are not to scale. It's just because it's hard to format things. Alright, what about this one? Slightly more difficult because it's not just straight up numbers, it's expressions, but you can still do it. What kind of angle relationship do these have?
Consecutive interior.
Consecutive interior again. What do I know about their measures?
Equals 180.
So we're going to write an equation. Alright? 3x minus 10 plus 5x plus 30 equals 180. And then you're going to solve that for me. All right. Any conclusions? X equals 20. All right, everybody get that one? All right, what kind of angles are these?
Funding.
No, I just want to know what X is. Corresponding. These are corresponding. What do I know about corresponding angles? They're equal.
Oh.
Only the consecutive ones are going to be 180 supplementary. So I would just say x plus 80 equals
Equals 5x.
equals 5x. Got it. So x is 20. 20 again.
We like
All right, everybody see how we do that? Well, no, you would have gotten negative x equals negative 20, and then divide. All right, slightly more complicated. Same process though. Now we're going to be doing two variables. It's important you guys know which one you need to solve for first. Okay, number 5. Which variable do I have to find first? Okay. Look at the two angles that have an x. What relationship do they have?
None.
None yet. What can I do?
Up there. Consecutive interior.
You can
Vertical that is.
move the 86 plus x using vertical. Now, what type of relationship do they have? Alternate? Consecutive interior for the x, right? When they're consecutive interior, what do I know about their measures? Okay, so write an equation. If I do that in my head, 3x plus 96 equals 180. You add them, and then subtract, and then divide by 3. 84. And then divide that by 3. 28. Good, finishing at 28. How do I find y?
Vertical strip plus 10.
Okay, so these two are vertical. You can still use stuff from each one to help you. So yeah, we're just trying to find the variable. So you're gonna plug x in. 2 times 28 is 54. This angle is 66. So what's the measure of y?
62.
I plugged 22 in. I'm sorry, 28. 2 times 28. 2 times 28 is 56. Add 10, you get 66.
So on the test, if you get some problem with this, do we have to write the condition? Is that
Yeah.
So we don't have to write the.
I need to make sure you guys understand like what the relationship is with the parallel lines. We've already practiced with vertical. All right, is everybody okay with that one?
Yes, ma'am.
All right, what about number 6? We have a hashtag going on, but both pairs of lines are parallel. No, we have no evidence that they're 90. Do the x and the 92 have a relationship right now?
No.
So I'm gonna have to shift stuff so that they do. Exactly. If I move vertical, they're still gonna be separated from each other.
Can you put the X and like put it on the other side? Alternate.
Using what relationship?
Alternate.
Well, they don't have the little boxes saying they're perpendicular.
But they're
I
parallel.
understand that they're parallel.
Oh,
Those are somewhere I could put the x.
Yes.
They're on the opposite side.
What relationship am I using? Corresponding.
Why was I thinking of that?
These 2 lines right here are parallel, so I can use corresponding angles to move the x over. Corresponding angles are congruent, so if this is x, so is that. So now the x is over with the 92. They're in the same region of the picture now. You can't, using alternate interiors, you could move the x here as well, if you wanted to, if you use alternate interior. It really doesn't matter what relationship you use. You can also move the 92 if you want. Yep. So now, depending on which way you did it, you're going to be using consecutive angles. All right? What do you guys know about consecutive angles?
They equal to 180.
They do equal to 180. So that means yes, it should be 88.
I got 68. I'm stupid.
We use corresponding.
Wait.
Use corresponding to move the angle.
Oh,
Use it
we
to
can
solve.
write that down.
No.
Oh, okay.
You guys don't have to, yeah, because 180 minus 92 should be 88.
I can't read that.
You guys don't have to write down the relationship you use to shift the angles. I just need to know which one you use to solve. Okay? I'm gonna let you guys try number 7 on your own.
Wait, just to
Do 7 and 9 for me, please. Hold on 8 and 10.
2x is vertical from 3x minus.
Yes. Hold on 8 and 10. Go ahead and do 7 and 9 by yourself.
Manya, just do this word. Your name here.
Or 3. You have to draw a little.
Y, right?
Oh,
Okay.
Negative x equals negative 50. Oh, I didn't even know why. Hey, when you move the line this way. What?
Oh, like oops, like oops.
Anya was 3 times 16. 3 times.
Wait.
That was
2 times 3. I almost pressed on the wrong one. Can you move this over here? Okay. So it's hard to like on the three. By the way, I can make you think about the difference in our.
Got it, wait.
So then you do it all everything got the big
one. So I think do that.
Did you get tons today? Or I can get tons.
If I ever find
The 2x.
Okay, so they
And why would that be? Don't make up any line.
No, just
why oh, okay, 75 minus 5 or something. Oh, I've seen this. I used to play
Actually, when you guys finish 7, pause for a second. 'Cause there's something I have to say about number 9.
Finish 7.
Yeah, yeah, that's what I did. Yeah. I think that's just a package.
I love reading. I hate my Alright, hopefully, look up. Hopefully you guys have at least finished number 7. Should have gotten something like that. Although there are other ways you can find them besides the ones that I use. I use vertical angles to solve for x. And then I plugged in x, I moved the y here, and then I plugged in x and did consecutive. Nope, just kidding. I did these two right here, which are consecutive exterior. You could also do consecutive interior. That doesn't matter. But you should get 15 and 150.
Okay.
Yeah, there are 2 different ways that you can find things. Vertical angles. Is everybody good with those? 15 and 150? Okay. We'll get to number 9 in a second. For number 8, it looks simple, but there's something you have to be very, very careful with. How would you solve for y?
Oh, for why?
Can you just use the y and the 80?
You can do the whole thing. Oh, because not y and 80.
Or consecutive
You get
interior.
consecutive exterior angles.
Move the y here.
Yeah.
Why?
I don't know.
What?
Go ahead and do that.
Oh,
why
Like, you just be like, you get rid of
Get rid of which this one? No, you use that one. That's the personal.
get rid of the random line.
Which one?
Like, you know, when there's like the V, the other side.
Yeah.
No, there's like the straight, like this section, and then there's the V. I don't want the other one.
No, yes, you do. Guys, listen. So you guys have a really good idea to take lines away, but why are you trying to remove the parallels?
Wait.
Yeah, don't do
You
it.
need to
Take away the one that's like.
Oh, take away the V. Or
Take
the
the
V.
diagonal one.
Take away the diagonal one.
You don't want this guy.
No.
Take it away.
You don't want it.
It's annoying.
So then, what would the full angle be then if you take it away?
40 plus y. Easy. Okay, let's go home.
You have to use them together. So sometimes there's an extra line you have to get rid of. So now what's the relationship between those?
Consecutive interior angles.
Yes. And they should be 20. Good. My marker would cooperate. Ooh, whatever. So you add them. It should be 60, I believe. how we did that? If there's an extra line that's breaking up the angle, you gotta take it away. Don't try to remove one of your parallel lines. That's the problem. Everybody good with that one?
Yeah.
Cool. Anybody venture into number 9 and notice something about that one?
Oh, I noticed this.
What do you notice about number 9?
Is that you can't do anything until you move one of those X and Y.
Actually, they're fine where they are.
Oh.
You could move them if you wanted to, but they're fine where they are. Okay. So we could use a linear pair. I'm looking for more broad linear pair. Yes. This right there you can use it. I'm looking for more broad systems.
System of equations.
We have to use the system of equations. Why? You guys need to be able to look at something and know whether to use systems or not. What is special about this one that indicates you have to use a system? Two variables in one label here for the angle. So you guys can use whatever angle relationship you see first. All right, we notice there's a linear pair, so I can add them together, right? You could use linear pair. You could also do consecutive interior. You could do alternate interior. There are a lot of different options. So you guys tell me, how do you want to write one of these equations? Okay, so then we're going to add these together and set them equal to 108. So that would be 3x, 3y, 1. Okay? Now, what's another relationship I could use?
75 minus 5.
These are equal?
Yes.
Yeah? Okay, cool. So we're going to do 3x minus y is equal to 75. Better to write it in that order. I only need 2 equations, so that's fine. I'm good with this. Now I just need to rework stuff, these systems. So, are these ready to add down?
No.
No. How do I adjust this?
8 times 3.
Which variable do you want to cancel? Y. It's easiest to cancel y. So if I multiply the bottom times, that'll work out for us. So I'm just going to cross it out and rewrite it. So negative 9x plus 3y, negative 200. Okay. 2 what?
225.
Cool. All right, then we add down. 8 plus negative 9. The y's go away. 180 plus negative 225. So if I have negative x equals negative 45, what's the value of x?
45.
Positive 45. So now I solve for y. Plug it in, solve for y. Go ahead. I know you guys know how to do algebra. Guys, solve for y, please. There are other ways.
There's 8 times 45.
8 times 45.
What is 180 minus 360?
180. Why 180 minus 2?
Negative 180.
And then divided by negative 3 or so?
Yeah. Why is it 60, guys?
Haley, you got it wrong. Y equals 60.
That's the part. I have no
Haley, Y equals 60.
All right, what's Y?
60.
60?
60.
Everybody get that?
Yes.
Cool. All right, we're gonna do number 10, and then we're gonna take a short break,
Got it.
and then we're gonna do number 1.
No.
All right, you can tell me how to approach number 10.
Number 10.
Yep. Number 10. Which variable would you like to start with?
X.
I heard X first.
Wait, hang on.
X is right here.
Take out the line.
Don't start taking lines out until you're absolutely sure you don't need them, because we need all these lines. So looking at X,
Can we put it like vertical across?
here,
Yeah.
this thing right here.
No,
No,
I'm on the right of that.
Like it's vertical. Okay.
So if we move the X, because it wasn't useful where it was, if we move the X using vertical, what relationship do I have that I could use to solve?
58
All
consecutive interior.
consecutive into this one.
Consecutive interior, which should be 180. What's the value of X?
124.
122.
122.
So it says 2.
Does everybody see how I did that?
Yes.
No? You didn't understand?
Put X there and then we can put consecutive between 180. You're 180 minus 58.
Wait, isn't it X equals?
Is it 118?
Yeah.
No, it's not. It's consecutive with the 58. What did I say?
I just try not to act. I just
180 minus 58 should be 122. All right, what relationship do I use to find Y?
alternate triangles.
So your Z,
Yeah.
alternate interior. Do you see how I drew the Z? There's your helpful strategy. So the two corners of the Z are alternate interior. What do I know about the measures? So Y is equal to
62.
62. Notice how I use the 62 for the Y, but I do not use it for the X. They each have their own separate transverse. We have the parallel lines, and there are two different transversals. We use them one at a time, one for each variable. Don't try to jump across the picture too much. Any questions on any of those?
So when you add
I'm kidding. Two separate transversals. The Y and the X. All right, any questions on those?
Yes, a little bit.
Should do with overlap.
So Y and the X.
I've definitely done that.
All right, we're gonna take a 3-minute break. Just for a quick break there, and then we're gonna do.
Can we just not take a break and get it over with?
No.
Take a quick 3-minute break.
I want to take a break. I see get it over with. Hey, you know that song?
Like, what is that?
What if you think Really? Okay, so they're paired.
All right. Hey, go ahead and move your phones back away if you got them out. We're on break just now. Well, I prefer that you're not on breaks, but people did. Go ahead and put them away, please.
There was a break.
Yes, Brody, listen. All right. These next 4 questions right here, were pulled directly from SOLs in the past. Okay? So these are the kinds of questions similar to, but can be wide variety of difficulty when you guys are working with parallel lines. So we're going to take a look at some of them and see if we can figure out how to proceed from here. This is a picnic bench table thing. The directions are giving you permission to assume that things that look parallel are. If you don't see that little note in the directions, you can't assume that things are parallel unless they have the little symbol. These don't have a symbol, but they're telling you that if they look to be parallel, that they are. So we have these lines right here, and then we have two different transversals. Does the one on the left even matter?
No.
No, so kind of ignore that. So how would I find the measure of these variables? Pick one and go. What?
122 and y make equal 180, which makes y equals to
58.
Okay, so y and the 122 are consecutive interior, which would be supplementary. So that gives you y is 58. Next one.
Also,
X. Z. Alternate.
Z is vertical from 122 to equals 122.
Okay, z is vertical.
Okay, X.
And then also X is
angles. So
Yeah.
X corresponding to what?
F.
Okay, so x and z are corresponding.
So they're 122.
You could have also said x and z are corresponding, or x and 122 are alternate interior. Could have also done it that way. That one's pretty smooth, right? Okay. What about this one? I want to know the measure of E and H, two different angles, or two separate angles in the picture.
90 degrees.
And 8. You just walk down the stairs and know where you're
Okay,
going.
so what?
So,
Corresponding to the
Here? Oh, this one. Yeah. Here? Or here?
Yeah.
Oh, okay. So everybody listen. There are a lot of different ways you guys can do this. Ultimately, you have to travel across the picture to get from here to here. And we're allowed to assume that all of these are parallel and all of these are parallel. So that's what the directions are said. So Michaela, notice that if we use these lines right here, this one and this one, right? This is corresponding, so that's going to be 115. And then you could also do this right here. These two are alternate interior. So you go all the way across the shape to get a 115 right there. You're allowed to jump over lines. Alright? And so then what would H be?
115.
It's also 115 because it's corresponding to E. So you can jump across the shape if you have all those parallel lines. You can skip over this middle one and just jump across the picture. As long as you're using a valid relationship. So E and H are both under. Alright, this question right here, we have a ramp or something. It says, what angles need to be congruent to force A to be parallel to B? You have 1, 2, 3, 4, 5, and 6. What two angles need to be congruent to prove that those are going to be parallel? 1 and 4? Why?
And all here.
Yeah, it should be angle 1 and angle 4 because they are alternate interior. But by that same argument, why can't I do 3 and 2?
Because they're exterior.
3 and 2 are inside the lines. 3 and 2 are right here. Why couldn't I have used those?
Because they're not inside the. Because they're out.
I'm looking. Keyshawn. Does anybody know why I can't use 3
They're
or
not
2?
using the same transversal.
Okay, so they're using a different transversal, but why does that mean?
But
Nobody knows?
they're not like touching A and B.
Angle 3 is right here, it's touching that. Angle 2 is right here, it's touching it.
It's like outside, it's like not in the,
No.
not like situated.
The explanation I'm looking for is you need to add an extra line.
Oh.
To add angle 2 and angle 3, and you shouldn't have to add extra lines to create angles that prove that they're parallel.
Why is that shape there?
Why is what?
Why put some ranch there?
It goes with the problem, it's a contextual question. You only want 4 and 1, because they create those angles with just the 2 lines in the transversal. Alright, this one is a true. Definitely something you're going to see on the SOL type question.
Really?
If you got rid of the transversal and did it along the line that's legal, would that
Use this one for instead.
yeah, you got rid of it.
No, you have to add this line to create angle 2.
But why is
Angle 2 is created with this extra line. You shouldn't have to add an extra line in.
but you use that line instead of
Use this line here.
or like if you got rid of I don't know how yeah, if you got rid of that one and you did the other
Yeah. I think that.
yeah.
You still need this line and this line to create angle 3 and angle 2. So you can't do it. Alright. This one you guys have to pay very close attention. There's a lot of information in the directions that they haven't put into the picture. You're going to have to do it yourself. Okay? I know that A and B are parallel. Add the mark. Listen, B, stop talking. A and B are parallel, so add the mark, please, into the picture. It's parallel. Angle 5 is 26. So just go ahead and put that number in. I know that angle 2 and angle 4 are congruent. I want to know what value of x will force L and M to be parallel as well. Whenever they tell you that they want to know what the x value that is to make them parallel, for the moment, we're going to assume that they're parallel. Because if we assume that they're parallel, that will help us find the appropriate x. So we're going to assume that all these lines are parallel to find the x that would result from that. All right, so tell me what I can do from here.
So, angle 4 and angle 5 are alternate interior angles.
They are.
And then angle 4 and angle 2 are congruent.
Okay. So I can shift. Well, I can shift the 26 to both of those angles.
And then angle 4 is a consecutive interior angle with the angle x.
No, it is not. Well, I mean, it is, but this line is not parallel to this one, so you can't use solving. It's two different lines that are not parallel.
Wait, don't form six.
So Brody, this line A, CA, and M, those are the two lines you would use with this transversal, but A and M are not parallel. You can only solve if they are parallel. Say again? Okay, 3 and 2 are a linear pair, so I could find 3. Well, what is 118? Is that right? Is that right? 118? No, it's not. It's 154? Okay.
What?
Angle 3, because it's a linear pair with angle 2. Which one? No, they're not. No, they're not.
Wait, but aren't they exterior expression?
Ideas. Time. 3 and X are no, because you would have to have this transversal keep going, and it doesn't.
2, 1, and 4 added to 180.
Okay. 2, 4, and 1, or 4, 1, and 2 all working together should be a straight line. So it means the angle 1 plus angle 2 plus angle 4 should all be 180. If I already have two 26s, What would that leave for 1? Angle 4 plus angle 1 plus angle 2. Oh man. But I think that one's, is that the 118 I was looking for before?
It's 180 minus 52, so
120.
120.
calculated.
Wait, why didn't
It's 100.
that's the
Alright, is everybody with me for the angle 1 I just found?
Yeah,
Yes?
but aren't 1 and X alternate interior
Yes.
angles?
Angle 1 and angle X are alternate interior. So once you find angle 1, you have, well, angle X, 128. See how many steps that was? It can be complicated like that.
And we're almost done, right? Okay, I'm gonna just do 128.
That is awesome. Okay?
I didn't know what you
Could you say that, X is like,
Yeah. Alright, I'm gonna let you guys do this on your own. I'm just gonna stick the answers up and then you guys can figure out as many of them as you can. Where's my answer key? I have it.
and then.